In this lesson, we're going to talk about box and whisker plots. First, let's talk about what it looks like. This is what a box and whisker plot is like for the most part. There's our box and those are our whiskers. But if you notice, it's broken into fours. There's this part here, this part there, this part there, and this part there. And that leads into our first vocab word, quartiles. Quartiles is how we separate this box. So there's a bottom half. Look at it from here to here. And then the median of that bottom half is this guy right there. And we call that quartile 1. It's the median of the bottom half of the data. And the median of the middle part of the data, which is actually the whole line, would be this part right there, Q2. And that's also just known as the median. And then if we look at the median of the top half of the data, that would happen right here, and that's Q3. So those are quartiles. It's the median of the bottom half of the data, median of the top half of the data, and the median of the whole data. The lower quartile is the median of the bottom half of the data, right here in purple. This right here would be quartile 1. The upper quartile would be the median of the top half of the data, so right here, quartile 3. The interquartile range, that's the difference between the lower quartile and the upper quartile. So that's going to be Q3 minus Q1. That's the IQR, also known as the interquartile range. That's where 50% of your data falls, but the middle 50, that's an important part of the data. That's the middle part of your data, the middle 50% of your data. And you find that by doing Q3 minus Q1. Box and whisker plot, that's what this is right here. The minimum value is this value right there, the smallest data value. This is our minimum. And the maximum is on the other edge. That's this point right there. That's the max. We have a min, we have a max, we have the lower quartile, which is the median of the lower half of the data. We have an upper quartile, meaning the top half of the data. And those 5 points make up a box and whisker plot. So if you could figure out the median, Q1, Q3, min and max, you got your box and whisker plot. Let's do it. So here's our first example. Create a box and whisker plot with the following data set. First, they want us to find the median. But to do that, we have to put them in proper order. We have to rearrange it. That's going to be 81, 85, 88, 90, 91, 94, 95, 97, and 100. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 terms. The middle is going to be the 5th one. This is our median. So 91. This is going to be our Q2. And now, next we want to find the median of the bottom half of the data. So again, this is our middle. The bottom half of our data is this guy. So we have to find the median of these guys. 81, 85, 88, and 89. So there's 4 things here. The medians have to be the average of the middle 2. We have to add them up and divide by 2. So 85 plus 88 divided by 2, we're going to get 86.5. So that's our Q1. Now we have to find the median of the upper half of the data. Same problem here, where we have an even number. We're going to take the average of the middle 2. Here's our upper quartile. And we're going to take the average of the middle 2. So 95 plus 97 divided by 2. It's 96. That's for Q3. And then our last 2 data points, the minimum and the maximum. Those are the easiest ones. The minimum, lowest value, 81. The maximum, the highest value is 100. Let's write out all our information. Our minimum is 81. Our Q1 was 86.5. Q2 was 91, or the median. Q3 is right here. Q3 is 96. And the max is 100. So let's make our box and whisker plot. First start with the minimum, 81, right there. That's our min. And then let's put a line for Q1. 86.5 right here. That's our Q1. Then I'll make a line for Q2, 91. That's right here. That's our Q2. And then we're going to make a line for our Q3, 96 over here. That's our Q3. And then our max is 100 right there. How do we make the box and whisker plot? Well, first we connect the min to the max, like that. And then with our little lines here, we make a box out of it. So that's our box and whisker plot. Find the interquartile range. That's easier than it sounds. It's just Q3 minus Q1. So that's going to be this guy minus this guy. 96 minus 86.5. That'll give us 9.5. That's how you do a box and whisker plot. Now that we know the gist, let's do it again a little faster. So we're going to do it this one. I'm going to rewrite it real quick. We're going to go lowest to highest. That's going to be 72, 73, 75, 77, 80, 81, 85, 87, 88, and 89. So in this case, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's not going to be an exact middle. 10 divided by 2 is 5. So it's going to be after the 5th one. So 1, 2, 3, 4, 5. So it's going to be right here. That's the median. There's no middle for it. How do you find the median? Well, if there's no middle, we're going to take the average of the middle too. 80 plus 81 divided by 2 equals 80.5. That's our median. The good news is the Q1's a lot easier now. The Q1 is these guys. Now there is a middle. 72, 73, 75, 77, and 80. Because the median's right here. The lower half is all these numbers. Now there actually is a middle. It's 75. And the same thing with Q3. It's all of these guys. And they have a middle also. 87. The minimum value is the lowest. 72. The maximum value is the highest. 89. And we have everything we need. We have all the 5 key points. Let's write it down. Min was 72. Max was 89. Q3 was 87. Q2 is 80.5, and Q1 was 70. We have all our data. Just make our Box and Whisker plot. The lowest one's 72, max is 89. I'm gonna connect those right away. Q1 is 75, that's right here. Q2 is 80.5 right there. And then 87 is our Q3 over here. And there's our Box and Whisker plot. And if I want the interquartile range, that's gonna be Q3 minus Q1. So that's gonna be 87 minus 75, and I get 12. Last little thing. Let's talk about outliers. Well, outliers are data points that are way outside the data set of the rest of it. The data value that's extreme compared to the rest of the data set. Outliers could pull the mean value down if the outlier value is small, or pull the mean value up if the outlier is big. If you have an outlier, it messes up with your data. Let's look at what it does. And let's look at this data set here. What is our outlier? It is the 3. Everything else is in 30s and 40s, and that 3 is way down. So let's find the mean with the outlier in there. And we're going to count them up. 32 plus 35 plus 3 plus 36 plus 37 all the way to 34. And we're going to divide it by, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Divided by 10. Now put it in our calculator. We're going to get 332 divided by 10, which is about 33.2. So that's our mean with the outlier. Now let's take away the outlier and do the mean again. But this time will be 32 plus 35 plus 36 plus 37 all the way to 34. And now, since we don't have the outlier anymore, we're only divided by 9. Put that in our calculator. We're going to get 36.5 as our mean. You can see right there, the outlier brought the scores down. The outlier was a really low score because these were scores not attached to that. It brought the scores really down. We made it lower. We can do the same thing with this one here. In this case, look at our outlier. It's at 98. That good score. Someone got 98 on that test. Let's say this is a test. Everybody else failed it before. If we find the mean with the outlier, so 43 plus 46 plus plus 47. All over, in this case, we have 8 data points, and that's going to give us 439 over 8, which is going to be about 54.9. Now, if we take away the outlier, we cross that out, and now we only have 7 data points. In this case, we get 48.7. Since the outlier was higher, it brought the scores up, but made the scores higher. That's what an outlier could do to a data set, so you want to watch out for them. And that's the lesson.